Let's look at part B. Okay, so the request here is to have a transfer function in terms of V out over V in. So we want V out over V in. And for this, we're going to make excessive use of Ohm's law. So just as a quick reminder, Ohm's law can be represented by this triangle because it relates current, resistance, and voltage. Okay, so we can say that I is equal to V over R, or V is equal to Ri. Okay, so to find the output voltage, V out is going to be equal to the total current in the circuit. So let's just put intermediately I here for our knowledge. I, which is the current, times R. Okay, but we don't know what this current is, and we're not going to have it in our final equation. But let's try and solve for I anyway. So we know that I in the circuit is going to be equal to the input voltage, V in, divided by the total resistance of the circuit. And the total resistance of the circuit will be the resistance, R, plus the impedance, which is effectively a resistance, due to the capacitor, which would be ZC. Okay. And in the exam question, it does say that ZC is equal to 1 over CS. So we're going to just substitute that. So V in over R plus 1 over CS. Now I'm just going to simplify this and solve it a little bit more. So we've got V in over RCS. Let's put it over a common denominator. And that's going to be CS plus 1 over CS. And to further simplify that, we then have V in times CS over RCS plus 1, like that. So that's starting to look a bit familiar, hopefully, as a transfer function is. Okay, but that's still solving for I, the current. But remember, we can get rid of this I by saying that I is equal to V out over R. So I can say that V out over R is equal to V in CS over RCS plus 1. Okay, and solving for V out over V in is equal to RCS over RCS plus 1, and that's the answer.